Dear learners, welcome back to NPTEL online certification course on novel drug delivery system. I am Dr. Satish Dyavanapelli, Assistant Professor at Department of Pharmaceutical Science and Technology, Institute of Chemical Technology, Mumbai. In our novel drug delivery systems, we are discussing on new topic, that is mucosal drug delivery systems. So, in our previous class, we discussed the topic, that is introduction to mucosal drug delivery system, and there we have discussed the concept of mucoadhesion. Then we discussed on the what are the mucoadhesive drug delivery systems, and then we focused on what are the ideal characteristics for a mucoadhesive drug delivery systems, and then we seen advantages and the limitations of the mucoadhesive drug delivery system. Then we discussed the role of mucus and in the drug delivery systems, and then we have seen the functions of mucin. Also we have discussed the role of mucociliary clearance of the various drug delivery systems, and then we have discussed the one of the case study which the researchers developed Monteleucast mucoadhesive films, which used for the treatment of asthma and the other applications. So, today we are going to discuss on some other interesting topics of mucoadhesive drug delivery systems. So, today we will see on the mucoadhesive polymers, which are bioadhesive polymers, and what are the ideal characteristics of such polymers and the classification based on the various parameters. Then we will focus on mechanism of mucoadhesion, and if time permits we will see some other topics in today, and then we will see in upcoming classes. So, here as we know that polymers has a major role in entire drug delivery systems. You can see in the nanocarriers, there we have discussed various types of polymers and their dosage forms. And then if you see in our previous lectures, in the target drug delivery also we have discussed on various types of the polymers which are response to the pH and the temperature and other type of stimuli responsive mechanisms. And then come to the oral controlled drug delivery systems, and again there we have seen various polymers which they have the different release mechanisms. Now again coming to the gastroretentive drug delivery system, there also we have discussed the stimuli response, and also we have seen the mucoadhesive and various types of the properties of the polymers which we used for the gastroretentive. And here also we are discussing on the polymers which are bioadhesive. So, one thing is very clear that the polymers has a crucial role in developing the novel drug delivery systems. Either it may be any type of properties, but the polymers has a major role in the novel drug delivery systems. So, today we are going to discuss on the bioadhesive polymers. To make bioadhesive system or mucoadhesive system, your polymer should be bioadhesive or mucoadhesive, right. So, the polymer it may be from natural source or maybe synthetic or semi synthetic that must bind to your biological surfaces. It may be cells or tissues or organs where the mucus is present. So, that is the definition of the bioadhesive polymers. Yes, mucoadhesive polymers that will specifically bind to the mucus layer. And what is the function which will works as a biological glues which will stick to the site of administration. What are the key features? Your polymer should contain the hydrophilic groups which are OH, COH and NH2 that will help for the hydrogen bonding. Your polymer should contain any type of the functional groups which involve in the as in a water uptake molecules that will activated by the moisture which is called as wet adhesives. And your polymer should have a feature that should have a stronger adhesion when allowed to dry after application. This is also we have discussed in our previous classes as an ideal characteristics for the mucoadhesive drug delivery system. So, strong adhesion is very, very important, and this adhesion strength will depends on the three things, that is hydration level, polymer flexibility, interaction with the mucin. This will going to discuss on the factors which will influence the mucoadhesion, and there we will discuss all type of these factors. So, here we will see what are the ideal characteristics for a mucoadhesive polymer. Now, before going this, we will try to understand once again the role of the mucus and interaction with the mucoadhesive systems. Now, this is the carrier, so which is prepared by the polymer and that have a mucoadhesive properties. Consider chitosan, and here is the mucus layer, this is the epithelial cells and this is the mucus which contains the mucin, and after administration the carrier will interact with the mucin and it will undergo the interaction deeply with the functional groups of the polymer and with the mucin content, and further it will undergo the uniting of these two things and it will further it will undergo cell uptake. So, this is a process of a mucoadhesive drug delivery system. Such polymers need to have some ideal properties. Yes, your polymer should be safe and that need to be biocompatible in human beings. So, that should not show any toxicity, that should not be non-immunogenic and that should not provide any toxic metabolites after the degradation. Second is biocompatible. Your polymer or your mucoadhesive system will not involve any type of complications after the administration. The simple which will not show any toxicity on the cells, and the second thing that your polymer material after administration, it should not release, it should not affect your RBC, that means that should not undergo hemolysis of the RBC, that is called as biocompatible. There are so many studies are there in the biocompatibility. So, especially cytotoxicity and the hemolysis are the two major studies we perform for the various nanomaterials. for biological applications. As we discussing this point, your material should be strong adhesion as well as that is easy to removable, because when you want to terminate the therapy, and that should be easily removable and that should have the strong adhesion properties, and your mucoadhesive polymer should be site specific and that should need to be stable at various conditions. Either you can select based on the pH sensitive, temperature sensitive and other applications, but your polymer should be site specific and that should be stable at throughout the various conditions. Also we discuss compatible, that means your material should be compatible with other ingredients and active molecules that should not affect the therapeutic efficacy, safety of the other components which are used in the dosage forms, that need to be performed in the pre-formulation studies before performing the actual studies. We need to compare the incompatibility studies of the polymer with the drug and as a physical mixture, then we will understand the performance of polymer with the drug. Then hydration balance is very important, because after contact stage the water molecule will enter into the your carrier because of the presence of this water from the mucin that will reach to the your carrier. So, such cases the hydration balance is important, that should not undergo complete wet and that should be balanced, because one principle, one theory says that it is a wetting theory which help for the mucoadhesion. Hydration balance need to be maintained, and flexible chains are very important, because at this stage, at the last stage, the interaction with the polymer and with the mucin is very important. If the chains, polymeric chains, if they are flexible, that can easily interlink or undergo the interaction with the mucin. So, your polymer chain should be flexible to interact with the mucin. And yes, after taking off water, your polymer need to swell and retain for longer time, which will help for the retention as well as for the control release. So, swelling and retention properties also very important for a mucoadhesive polymer. Not only pH sensitive, we can also consider even temperature sensitive also. So, both cases are very important for the treatment of like various locations. The pH range will vary from 1 to 7.4. So, such cases pH sensitive also has a major role, and also based on the temperature your polymer need to be selected, and the cost effective, that need to be balanced. Your delivery system is performing very well, but the cost of the polymer is, if it is very high, then people will not offer, and even the technology also will suggest to go ahead with such polymers. So, your polymer should be cost effective compared with the conventional formulations. So, we can also classify these bioadhesive polymers based on their sources and based on their solubility and based on the charge and based on the mechanism of adhesion. So, first we will see the classification of the bioadhesive polymers based on the sources. Now, these can be classified into two categories. One is synthetic, second one is the natural. Again, in the synthetic we have a cellulose derivatives. In that we can see carboxymethyl cellulose, sodium CMC, hydroxypropyl methyl cellulose, hydroxypropyl cellulose, methyl cellulose, hydroxyethyl cellulose, thiolated carboxymethyl cellulose, and this thiolation will help for the strong adhesion with the mucin which contain the sulfur groups. So, there it forms the sulfide bond. So, that is also very important. And the second class is cyanoacrylated based synthetic polymers. So, these are the two varieties of cyanoacrylate polymers. Polymethacrylic acid bases, so carbopol, polyacrylic acid, polyacrylates, copolymers with the PEG and polycarbophiles are the best example in the class of polymethyl acrylic acids. And there are other polymers which comes in the synthetic category, which are polyvinyl alcohol, polyvinyl pyrrolidine, again thiolated polymers which are very commonly used in the mucoadhesive drug delivery system. So, these are the some of the natural polymers, especially we use chitosan, gelatin, hyaluronic acid, and then we use pectin, sodium alginate and the carrageenan. Yes, of course, we use various other types of the polymers also, but based on the routes of administration, we will select right type of material. So, these are the based on the source, and now we will see the classification of the polymers based on the water solubility. So, here these are the water soluble polymers and these are the water insoluble polymers. Again same class cellulose derivatives which are water soluble, and the polymethyl acrylic acids also water soluble, and then these are the some natural materials and the others. And the water insoluble, yes, chitosan is water insoluble because of the hydrophobicity, and second thing high molecular weight. But after various treatments and hydrolysis, we can also get low molecular weight chitosan which is water soluble. For this case, the chitosan we need to use acetic acid to dissolve the chitosan, and ethyl cellulose and the polycarbophiles also the best examples of water insoluble polymers. Now, the third class based on the charges. So, these are the charge on which will present on the polymers. That class that can be classified into three classes. One is cationic, second is anionic, third one is uncharged, that is non-ionic polymers. So, positively charged polymers after the dispersion into the medium or aqueous system which will show the positive charge on the surface. The aminodextrin which contain amino groups, here also you can see, and even chitosan which contain NH2 groups which will give the positive charge, quaternary chitosans and trimethyl chitosan also. So, these are most commonly used in the drug delivery, especially when you want to complex with any type of negatively charged molecules. So, this we will prefer. And another case, when you want to interact with the mucin because it contains the sialic acid, such case also will help for the interaction with the mucin. And the anionic, yes, you can make a synthetic chitosan EDTA that will give the negative charge, carbopol and polycarbophil pectin sodium alginate. So, and the CMC and sodium CMC, this will give negative charge, most of them contain the carboxylic groups. So, carbonyl groups which will give the negative charge. Whereas, uncharged, so here which they will not show any charge in their surface, because of they do not contain any type of amino and carboxylic groups. So, which will not show the positive or negative charge, and comparatively, so for biological applications these have the low toxicity similar to the surfactants. So, classification based on the adhesion mechanism. So, this can be classified into 3 types of mechanism. In our upcoming slides, we are going to focus on other types of the mechanism also. So, these classification for the polymers only. So, here these polymers can be classified based on the adhesion mechanism. The first one is covalent bonds. Here we use cyanoacrylate, it will undergo the mucoadhesion with the covalent bonds, and these are the category of the polymers: acrylates, carbophil, polycarbophil, polyvinyl alcohol and cellulose derivatives. They will undergo the adhesion mechanism via hydrogen bonds. Electrostatic interaction, as I mentioned, chitosan and alginate and some other molecules or some other polymers we use as a positive and negative charge. Chitosan contain the positive charge and this will show positive charge and the negative charge in the water. Such cases we need to interact with the mucin by using the opponent charge. So, this is the electrostatic interaction mechanism which are involved for the classification of the polymers. So, here we are going to see the mucoadhesion mechanism. So, this mechanism is again divided into the 2 stages. One is contact stage, second is consolidation stage. So, in the picture also you can see how it works. So, contact stage is nothing but spreading, swelling of formulation, initiating deep contact with the mucus. So, this is a primary stage. This happens during the administration or attachment of your dosage form to the mucus, right. So, this is a contact stage, you can see here, this is a dosage forms, either it may be solid dosage forms, right. So, after administration this is adhering with the mucous membrane at different site, either it may be oral route or the buccal, vaginal, rectal, nasal, ocular, any type of routes, but which happens at the first stage is the contact stage, whether your route is any type of route of administration. So, initially it will interact with the mucous membrane, that is called as contact stage. At this it will interact with your mucus. That stage is very helpful for the second stage, that is called as consolidation stage. So, here the mucoadhesive material are activated by the presence of moisture, nothing but the water content which is available in the with the mucin. So, that is called as the interaction stage. So, here the water will further will interact with your dosage form. So, that is called as consolidation. This stage is further divided into 2 stages. The first one is dehydration, second one is the diffusion stage. In the dehydration stage, what happened? You can see the pictorial representation. the difference in the concentration gradient draws the water into the formulation until the osmotic balance is reached. Now, you can see this is the mucous membrane and this is your dosage form, mucus dosage form, and what happened after administration in stage 2 in the consolidation. So, dehydration is happening, nothing but the water is moving from the mucous membrane to the mucoadhesive formulation. So, here there is a dehydration layer is forming because of the water uptake into the mucus system. If your polymer is wettable or strong in the water uptake, so it will rapidly take up the water and it will undergo the dehydration stage, that is the first one. And now here you can see the another thing, that is a hydration which is shown in the light green color. So, hydration region is forming. So, once it is balanced, then it will stop the water uptake. So, this stage will end up here, then it undergo the second stage in the consolidation stage, that is called as diffusion. Diffusion is nothing but moving of the your carrier into the your mucus layer, and further it will enter into the deeper layers of the cells. The mucoadhesive molecules and the glycoproteins of the mucus mutually interact by means of interpretation of their chains and the building of the secondary bonds. So, here you can see this is the mucus and this is the membrane, and these are the blue color represents the mucin chain and the green color represents the dosage form. So, once at this stage, that is in the consolidation stage, so you can see there is an interpretation or entanglement of the polymer with the mucin will happen. So, that is called as a consolidation stage. So, with this, like with the contact stage and consolidation stage, these both are very important to show the mucoadhesion. So, these are the various types of the mechanisms, or you can say the stages which are involved for the mucoadhesion. So far we have discussed on the what are the biopolymers or bioadhesive polymers, then we have seen the what are the ideal properties of bioadhesive polymers, then we have seen the classification of bioadhesive polymers, and then we have seen the mechanism of mucoadhesion. So, in our upcoming classes we are going to discuss on the various theories which are helpful to understand the mucoadhesion mechanism, and then we will see some of the mucoadhesive dosage forms and the routes of dosage forms and other applications of the mucoadhesive formulations. With this, I am going to stop today's lecture. Thank you so much.